Everybody, I'm going to go ahead and get started. Welcome to the 2:40 session, starting right on time. This is from Nuix on edge computing. And what I'd like to talk about today is define edge computing, do a little bit of definition, talk about how edge computing directly contributes to security objectives, then push it a little farther into insider threats specifically, and give you some examples of how Nuix is actually using edge computing to accomplish this problem or help this problem of insider threat detection and investigation and even protection and blocking. So just to start with, my name's Hoke Smith. I'm Director of Cybersecurity and Analytics at Nuix, and I'm glad to be with you today. How many of you here have heard of Nuix before? Anybody? Okay, there's a couple. Good. I like to say we arm our customers for today's threats. This is not a slogan that's been approved by our marketing team, but I think it tells the story pretty well. So whether it is a cyber threat or an insider threat or a compliance issue or just a litigation matter that your enterprise is facing, Nuix works sort of across that spectrum to help you. First and foremost here to protect and to support real-time detection, triage, and investigation. We have our adaptive security product, and that's kind of the focus of this presentation today. Nuix is very well known for our investigator workstation product. It's in use, I think, by around 2,000 customers around the world for forensic investigations, deep dive investigations, ingests all kinds of data, indexes that, makes it available for search. If you've heard of Nuix before, you might have heard of us in the context of the Panama Papers investigation a few years ago. And it was this product that was used to process millions upon millions of documents that were made public as part of a disclosure during this Panama Papers event. And then finally, our e-discovery workstation product is probably responsible for the biggest footprint we have. I think lots of different statistics on how widely used this is. 8 of the 10 largest investment banks use Nuix for e-discovery. So this is kind of how we help across the spectrum of a threat. But I wanted to really, as we get into talking about edge computing, level set a little bit. I won't define it for you, but I'll at least share with you how I'm thinking about edge computing and what the advantages of edge computing are, and then we'll apply those to security. So if you've heard of this, Gartner's actually called it one of the top 10 technology trends, both in 2018 and in 2019. The idea of edge computing is that you can boost performance, reliability by performing analytics and processing on resources that are neither on a sensor device or on an endpoint or in the cloud. They're at some intermediary layer. Sometimes that's called fog. Sometimes it's called cloudlets, as in the diagram here. The idea is that this edge computing is used to support processing intensive applications that the endpoint device itself can't really support. So a good example would be to think about augmented reality, an AR application, where you're holding your phone up, walking down the street, and you basically point your camera at the Empire State Building. And your mobile device sends an image of the Empire State Building to a local intermediary like a cloudlet. The cloudlet immediately responds with some metadata about the Empire State Building. So this is technology that really accelerates responsiveness. It's really designed to reduce latency and provide superior performance for these intensive applications. There's about 30 to 40%, depending on what report you read, annual growth expected in this segment of edge computing over the next few years. So this is kind of a model for edge computing. At Nuix, with the adaptive security product, we've kind of pushed beyond the cloudlet. So we're actually pushing logic and computational ability from a security standpoint all the way out to the endpoint, out to the end device. And that really allows us to realize some of the key advantages of edge computing. If you're interested in this topic and you haven't already, There's a really good article in IEEE's journal Computer from January 2017. It's by, I believe, the head of the computer science faculty at Carnegie Mellon. And his article is just called The Emergence of Edge Computing, and it is extremely clarifying in sort of describing the boundaries of this. He talks about 4 key advantages, and lays them out, I think, really effectively. And I'll just go through these quickly. We'll talk about them kind of in general and then as they pertain to security. So first one is responsiveness. So I gave you the example of responsiveness in the case of augmented reality, where the user can't wait to see the metadata about the Empire State Building. He or she needs an immediate response from their application. So cloud services are used to accelerate responsiveness. In security, that sort of translates into being able to respond in real time or near real time to a threat. So if you have a fast spreading piece of malware, a worm, for example, or some sort of threat that's occurring actually on your end computing device, the responsiveness of this edge computing allows you to block or defend against that in real time. Scalability via analytics. So this is about the basic problem that if I start collecting full motion video from millions of IoT devices and all kinds of other sensor data, pushing all that up into the cloud becomes a major problem. I have to ingress a ton of data, and that means I need a lot of bandwidth, I need a lot of storage to handle it. So with analytics actually out at the edge, we can reduce that, right? Because we can only send up information that's either we know is indicative of threat or we think is likely going to be relevant in some investigation of threat. And that's, again, sort of to tie back to how Nuix is handling this with the adaptive security product, is we're performing this logic out on the endpoint, out on the server, PC, or laptop. We're saying this is likely a threat, so send that back. Or this is likely to be relevant in a threat investigation, so send that back. But don't send back every piece of data that the sensor is collecting, right? Because an endpoint agent at the end of the day is a sensor. It's collecting a lot of information about what's going on the system. Next is privacy. So GDPR kind of is a nice topical thing to hang the concern of privacy on, but increasingly people are concerned about having personally identifiable information in the cloud. So what edge computing allows us to do is to sanitize, anonymize, pseudonymize, whatever term you want to use. I think I've heard the term denature, to denature data before it makes it up into the full cloud. So if you think about a scenario where an endpoint agent is actually collecting information about a Windows computing system and collecting things like the user's name, user's account name, the name of the host in which activity is taking place, the IP address of that host. These are all things that tie back to an individual person. And so increasingly, not quite as much or as rapidly in the United States, but certainly in the European context, there's a desire even for security monitoring, for PII and personal information, not to make it up into the cloud. So edge computing allows us to do things like obfuscate the last octet of the IP address or the username or the host name in a way that makes it more difficult for an unauthorized person to discover the full identity of the individual we're alerting on. So, and finally, availability. If we're implementing this edge computing effectively, then the presence or absence of the cloud goes down because of networking problems in the cloud itself. If there's a denial of service attack, if I've implemented edge computing on my end user device, then I'm not dependent on connectivity to the cloud. And there again, this is something that we've implemented in the adaptive security product. So as we go into this, and I'll show you how we're applying analytics in real time out on the endpoint, let me just give you some context for the Nuix product here. So this is just a depiction of adaptive security. Looks like it doesn't look super good on this at this screen resolution, but what we're doing out on the endpoint, out here on the edge, is we're doing protection, detection, providing data for response and investigation, and providing tools for remediation. So this is out on my edge. We're sending back via REST API to a operator's console, certainly alerts that are based on potentially malicious behavior. The operator, if he or she wishes to do an investigation, can also receive triage data from the host. Now, out here on the host, we're applying this edge analytics to suppress data that's not relevant in an investigation. So think of a situation in which I need to understand all of the network connections that a particular endpoint or host is making, but in the course of an investigation. But I know that my systems in my enterprise routinely make a large number of connections to certain servers that, as a part of normal course of operations. That data can be suppressed out on the edge so that it doesn't get passed up as part of my investigative response. Finally, the operator can also pass down remediation commands. Things like terminating process, isolate the machine, delete a file, clean up the registry for persistence, et cetera. So that's just a backdrop there for the adaptive security product as we go a little bit deeper into this logic out here, edge computing, how edge computing is being implemented on the endpoint. So this is just a little bit of a lifting up of the hood of what's going on inside the endpoint agent. So it's using, in the Windows operating system, a kernel mode driver. And this driver is looking across about a dozen different types of system behavior. And these are things like removable media insertions, file system writes and deletes, network connections, events in the Windows registry, all the way to keystrokes, print jobs, et cetera. So the agent sees all of these digital behaviors, and then it applies a set of rules in real time. And that allows it to take one of about 7 different actions here certainly to alert. So if I see something that looks as if it is a spear phishing attack, I can send an alert. Only going to alert on that. I'm not going to send back every event on the endpoint. Blocking allows us to prevent a process from starting up, to actually prevent ransomware from running, for example. Killing a process is a rule that gets applied after the agent is pushed out and sees something running that violates a rule. It can kill it in response to logic. Isolation is just quarantining, imposing a host-based firewall. Data suppression I mentioned a second ago. So data suppression says, don't even write this event to my local cache. This agent is caching everything on the endpoint in a rotating file. The suppression command says, don't even write it locally. The forward command is sort of a partner to that. The forward command says, send it back immediately to the user console. In other words, it's not an alert. It's not something that I think is malicious, but it's data that's going to provide context, or that can possibly provide context for investigations or deep dives. And then finally, screenshotting is something that sort of gives the operator the ability to, picture, is a much better way to tell a story than many, many words. So screenshotting is a way to say, I'm not exactly sure what they were doing, but I've taken a series of screenshots for 2 minutes that we kicked off as soon as they visited XYZ website. And so that's a way to close an investigative gap that we might otherwise have. So let's take a look at a couple of insider threat cases specifically. This one was actually just in the news because the Cincinnati FBI, there was a story yesterday on the Cincinnati FBI's work with GE Aviation on a case in which a foreign security service was seeking information about aircraft engines. So the scenario here is sort of modeled on a European defense contractor, actually, whose employee was sending sensitive intellectual property to handlers outside the agency with the goal of commercializing similar products or closing gaps in research and development. And if you study these cases, you know how specific these collection efforts can get. In this case, the sort of tasking for the collector was not just about engine designs. It was specifically about how containment was being tested for the turbine blades. So they're very focused. So in this case, the threat actor is acquiring sensitive data, copying it around, copying it to a single drive, emailing it out. In some cases, also running malware. So in this case, the malware appears to have been part of the actual exfiltration mechanism. In other cases, we've seen malware used actually to trigger the IT team to come in and re-image the computing device. That sort of blinds the forensics guys to what happened, so it's a way of covering your tracks. So what do we do with adaptive security on the detection investigating side? What can we do with edge computing? Well, one thing we can look at is file movements from designated directories, if we have particular shared drives, for example, that we're concerned with. And then we also have some interesting ways of preventing malware from running. So this is actual logic that's applied on the endpoint. As I mentioned, the agent is running these rules in real time. And I wanted to show this to you just to get very practical and specific about edge computing, because this is it in action. So you can see the actual rule set that's being applied out on the edge. A file in a monitor directory was copied or deleted. We're saying alert when. We have a file event, and it's a write or a delete or a rename. And it happened in a directory that contained the phrase sensitive data. So adaptive throws an alert. File copy to removable media outside of business hours. So a lot of our customers are very interested in what's going on with removable media. What this allows us to do is look and see, okay, is there a media device inserted in the machine? And is there an event that is a file copy that corresponds to that removable media device? And did this take place outside of work hours? All that logic's being applied, and then that generates an alert. Next, we deal with the malware. So in this case, what we're looking for is exploitation of MS Office. So if you're familiar with how these kinds of threats work, you know that Office is often used in a variety of different scenarios as a sort of vector, as a threat vector. But in this case, what we're looking for is Office actually spawning a process that's malicious, or spawning a shell program which is going to give the bad guy access back onto the end user's machine. So we're looking for, is Office starting up, and did my list of reader correspond to the parent path of the process that started this child process? And then down here, we're actually blocking that. So we're saying don't allow MS Office to run an unsigned executable or spawn a shell. So we're doing blocking. We're putting a straitjacket around Office in this situation. Second case is a bit more basic. So in this one, financial services company, threat actor is a departing employee who wants to take customer identity data with him so that he can go and recruit those customers at his next employer. What he's trying to do is get the contact data, basically by printing records from a browser, printing records, for example, out of Salesforce, if anybody is familiar with Salesforce.com. So what are we detecting and investigating? Suspicious printing. The logic at the edge that we're applying says, first of all, I'm going to maintain a user watch list, and if my user is on that watch list, and he prints a document that contains a term that's indicative of a topic I care about, then generate an alert. And then we're going to get a little bit more sophisticated here, because I don't necessarily want to see if one Salesforce screen is counted, is printed rather. I only care if it exceeds a certain threshold. So now we're going to actually set some variables here. We're going to create something called a Boolean called print counter and prints exceeded. Set prints exceeded to false until the print counter iterates up to a threshold that we care about. And so we're going to actually alert when our prints exceeded is true and the username corresponds to somebody on our user list. So we're able to put together this behavior around printing with the user, attribute this activity to a user to apply logic out at the edge. So the last case is around employee theft of customer data. So this is a healthcare organization modeled on a healthcare organization event that took place not long ago. The threat actor is an employee who's acquiring customer PHI, emailing it out. So what we're detecting is uploading to file sharing and then doing investigation on that event. So one of the things that we can look for with logic on the endpoint is compression. So a user might use Windows native compression, they might use 7-zip, they might use the WinRAR utility. So we're looking for command.exe actually being used to call the WinRAR utility here. So we don't actually have to see the process itself, we can see a child process that's being called by the Windows command processor. And then we can also look for things like suspicious data uploads. In this case, we're going to look for a particular IP range and say if the network protocol is TCP and the amount of data sent up exceeds a megabyte, then throw an alert. So that's the examples I have to share, and I just wanted to leave you with a couple of takeaways if you think about edge computing and security. So placing security logic out at the edge, I think offers a number of advantages today. First of all is this immediate response, right? If you're out there at the point of potential compromise, you have your logic there, you can stop the threat before it becomes a toehold or before it becomes a foothold. So you're really on the front lines. We can reduce burden on the network and on our storage infrastructure by performing analytics at runtime, out on the endpoint. Certainly secure privacy by anonymizing identifiers, and then also protect devices, whether or not I can get connected to the cloud. So I will just say thank you very much for your attention. I really appreciate it. I hope you guys got something out of this. I will be around here for a little bit after if any of you would like to discuss this further. Please also, if you're interested in the Nuix Adaptive Security product, you can find it at our website. Just go to Nuix-Adaptive-Security. There's my contact information. So with that, I'll just say thank you very much. Have a great day.